Do you have an intuitive grasp of what moles are? That's what usually messes people up. Let me do this. There is a number that represents mole. It's just like these. I call them counting numbers. They're like counting units. If I said go out in the parking lot and count how many cars are out there, and you came back and said, I said, in the parking lot. If I ask you that, and there were 18 out there, as in 1, 2, 3, 4, 5, 6, 7, 8, just the integers, and you went and you counted them, and you came back, and there were 18, you'd come back and say, okay, just as an aside, you want nearly every time, except for here, when we have some kind of numerical value, there's a numerical value, there's a unit. I always try to include a label to keep things clear. So if you came back and you were being proper, you'd come back and say, numerical value 18, and there's your label cars. And since I didn't give you any of these to work with, the only thing you're going to think is just to say 18 cars, and notice there's no unit. Those counting numbers that you've been using since you were in first grade, there's no unit. But if I said go out in the parking lot and come back and tell me how many dozen cars are out there, you come back and tell me but this time, instead of being a blank here, this is the label. How many refers to the numerical value. Here, before, there was nothing there. But this time I said dozen. So now you're going to have dozen. And the way the math works is you're going to go out there, you count 18 no unit cars. Just put it over 1. And now there's a conversion factor between no unit and dozen. I want this to cancel the no unit cars. 12 no unit cars is 1 dozen cars. That's your conversion factor. 12 dozen equals, this way I write it. 12 things equals 1 dozen. That's the conversion factor. And you're either going to use it like that, or you're going to use it flipped over, depending on the context. So you go out, you count 18 cars. On the way back, you're like, okay, he wants to know dozens. So you'd come back, you would do this math. Blank cars cancel blank cars. You end up in dozen. And the rest is divide 18 by 12. And you will get exactly 1.5 on your calculator. That's how you do the math all the way back in, right? Follow that, right? Okay. Everybody with me? Keep your intuition here. What if I said go out and count the cars? And I said instead of dozen, I said, how many pairs of cars are in the parking lot? The only thing you changed here now it's a 2. One pair of cars is 2 cars, no label. Cancel no label, you divide. 9 pair of cars. That cancels, get that many cars. Moles is exactly the same. I'm just going to erase this. there's still that blank. I'm going to put a much bigger number here, though. So do cars. I'll say helium atoms. And I need 1 mole equals so many helium atoms. This is one of the reasons people hate mole. Is 1 mole if I did that right, there's 23 zeros there. It is an integer, just like 12, 2, and 20. It's just a massively huge integer. You guys okay so far? The second reason this is difficult is we naturally have to use powers of 10 here, right? So the way we usually write this is 6.022. That's really what we use for the mole. And that's the number I'm going to put in over there. 1 mole equals this freaking many things. Ten and 23. 1 mole of helium atoms is 6.022 times 23 helium atoms. And now I'm going to put a huge number here just so it's all a little more sensitive. If I did 1.46 times 10 to the 23. It's still the same math problem, but I would attack it a little bit. And I'll give you this number for a test. If you really want it. All right, if it were me, I would rearrange that to 1.46, 10 to the 23. So I just kind of dropped these ones. I shifted this under here. I went ahead and canceled these. And I was left with moles of helium. And if it's me, I would just inspect this. These have the same power of 10, so that's just going to collapse to 1. So that just goes away. And then all I have to do in my calculator is that. .46 divided by 6.022, I get and one of the reasons we use that huge number is it keeps us being able to use numbers around this order of magnitude. It saves us a lot of trouble. Okay, so let me contrast. Okay, the question you're being asked here is how many helium atoms? Here, contrast here is, when you're asked this, how many, and immediately